Hey guys, so today we'll be solving the question called balance binary tree. हालांकि ये easy question है, but this question actually requires a pretty good understanding of binary tree, and we have to determine if it is a height balanced or not. So यहाँ पे there is a definition also which is given. So people what they do is that they refuse to read the definition over here and then they directly start writing them. So what it clearly says that how do we define a height balanced tree is that is a binary tree in which the depth of the two subtree never differs by more than one. Okay, it never differs by more than one. So what they eventually end up doing is that, okay, let's say for a given example, this I draw a binary tree. Okay, and this is a null pointer over here. Okay, now you have to tell me this is a null pointer. Then you have to tell me whether it's a height balanced or not. Okay, take a guess over here. Yes, it's a height balance because the height at this point will be a 1 and the height at this point will be 0, right? And the definition says that the depth of two subtrees never differ by more than one. Now, the depth of the two subtrees, that if you subtract the left subtree height and if you subtract the right subtree height, you will eventually get 1, right? So it never exceed 1, right? And that's where people actually confuse the question. So this is just for the clarification purpose. Now let's get started and see how we can eventually solve the question, right? Now the first thing you might realize is that let's draw a binary tree over here. So understand the fact that when we say that it should be height balanced, we have to determine if it's in height balanced. What we can eventually end up doing is that we first let's draw a binary tree to understand. Okay. Now see, I want to determine if my node A is height balanced or not. But I cannot tell node A because I have not visited its children. And similarly, I have not visited its right, like left and right subtree has not been visited for this thing. So I cannot immediately say that, hey, this node A is height balanced or not. So what I will do is that I will recursively break. So whenever, if you see, okay, how do you break down a problem? Okay, you you divide it into a smaller subtask. You divide it into a smaller subtask, and you say that to the left hand side, hey dude, I do not know if I'm height balanced or not. I do not know if I'm height balanced or not. What you can do is that I will give you two tasks. Okay, I will give you two tasks. First is that you return the height from this point onward. Let's say I get a height h1, and you return me height h2 from this point onwards, right? And then I will take a decision whether I am height balanced or not. As simple as that. Think like this. Now, the next thing over here is that we have to determine if it's A will determine if it's height balance when its left children and its right children will help him. So that's the thing. Now the responsibility will now come on the children. Now the children must decide that whether they are height balanced or not. And how they will decide is that they will then check their left subtree and they will check their right subtree. Okay, and that way they will determine. So the only way we can achieve this is that we can first ask the left children that, hey, what is your height at this point? And the left children returns that my height is 1. Okay, and same thing, we will ask its right children, hey, what is your height at this point? It will return 1. So I know that this is height balanced because 1 minus 1 is 0. So this becomes height balanced. And I say that, okay, how do I pass this information? Now, the surprising thing over here is that how do we pass this information back to A saying that, hey, we are height balanced? Okay, now let's try to understand. Okay, H1 was asking, okay, A was asking H1. You understand this fact? What is H1? H1 is basically the height of the subtree. Okay, H1 is basically the height of the subtree. And can you tell me how we can pass this information that A, oh, we messed up, I'm not height balanced. How we can tell using this H1 variable? Using this H1 variable, how do we tell? So if you can solve this now, dude, I'll tell you that तुम्हारा entire question solve हो चुका है. So what you can eventually do over here is that you can take a pause at this section. So try to understand what is height. Okay, कभी किसी का height negative होता है. Just try to understand. Does any person have a negative height? No. How can a person have a negative height? It means the person does not even exist. Something like that. So what you can do is that for negative values of height, we can pass this information that if h1 is negative, that means there is an imbalance. That is imbalance. So that's how we are going to pass this information from the left subtree to the root. Okay, and we are going to solve this. Okay, now you might ask me that, hey, how do we traverse it? How do we traverse it? It's very simple. See, there are only three orders traversal: in order, post order, and pre order. Now, in this given thing, we do not know what is the height of A. So, what we will do is that we will ask his left children, and since we began it from left, that means एक ही order traversal बचता है. I mean, see, not only one, sorry, but eventually, when you go left, the left needs to also know you cannot process the route directly now. Okay, you cannot process the route directly because now confusion post order in order में होगा, है ना? There only now we have removed pre order. Confusion will only start on the post order or in order because both traverse left side. But understand this fact: even for B we have not determined the height. Even for B we have not determined the height. So that means ki we cannot process the root node at this point. That means only one traversal order remains. That is a post order. So that's how you recursively think how you solve the problem. So now we can eventually say that ki hey, B, go and ask your left children. B, go and ask your right children. Check if they are height balanced or not. And according to them, then return the answer. So you know the code for finding the height of the tree? It's basically like 1 plus max of left and right. Okay. It doesn't matter. It always return 1 plus max of left or right. This is the answer of the height of the tree. Now we know that this value will always be greater than equal to 0. It will never exceed, it will never go -1. Now in the scenario it goes -1, that means we have found an imbalance between the tree. That's all, guys. That's all you need to do. So you recursively perform this operation. Now let's say that for this thing we have taken this information, but let's try to delete this E tree. Now, what will happen over here is that the information will be that A will, this is again a height balance. Okay, let me delete some more thing. Okay, now this looks better. Now, what will happen over here is that when B will return the height will be what? See, at this point, B is balanced. Understand this fact, B is balanced because there is no node on its right side and 1 minus 0 is 1. So it is within the boundary. But B, when it returns the height, it says that hey, dude, I am height balanced. Now you check if you're height balanced or not. So what information height h1 will be equal to 2. Now 2 minus 0 is what? Greater than 1. So obviously A becomes imbalanced. And how do we pass this information? We return -1. We return -1. Now understand why we are returning -1? Because height can be never be negative. If it becomes negative, that means something has gone wrong. So I will just show you the quick code how we can eventually write this. So this is not the correct code actually. When I try to write this code actually I tried it messed up. So in front of you only I'll write it out. If left is equal to -1, then we return -1. So what I was doing is that I was trying to use some flag to pass this information. I'll tell you my mistake also, though. It's not like I'm a perfect coder. Try to tell my mistake also. So I was trying to see what if I use a flag. Now using a flag, I realized that it's a why do we even need a flag? Because we can eventually pass this information to this given to this given thing, right? Using this height wala information. Sorry. So again, I'll tell you that if the root is null, then we return 0. And if we traverse on the left side, we traverse on the right side. Now you might be asking me that, hey, what is this -1? So let's say that when you recursively solve the left subtree, and somehow left subtree is saying that, hey, I'm not height balanced, that means I need to share this information. I do not need to further process it. I just return -1. That means you're ending it early. जैसे तुम्हें -1 कहीं भी मिल गया ना, just think that you will recursively avoid all the recursion. Like you will solve basically क्या होता है ना कि let's say कि at this point B has already declared its height imbalance. Do you think it makes sense to solve the right one? Do you think it makes sense? No, it does not make any sense. Because why do we need to do this operation? Because once we have already gotten this information from B that hey, this is height imbalance, if we solve this right subtree, it does not make sense. We just return answer. The question is only asking कि कितने height imbalance नहीं है, but the question is only asking कि true or false है कि नहीं है, बस इतना ही पूछ रहा है. So what we can eventually do over here is that we go on the left side, we check if it is -1. Again, we see कि अगर right minus left की value greater than 1 है, then we return -1. Otherwise, what we return is that we return the height of the given tree. Now, let's say that DFS root is equal to -1. तो क्या हो जाएगा, सॉरी, नॉट इक्वल टू -1. सो इसमें क्या हो गया कि अगर इफ वी गेट सम गुड पॉजिटिव वैल्यूज फ्रॉम हियर, इफ वी गेट सम गुड वैल्यू फ्रॉम हियर, इट मीन्स कि that is not negative. That means that tree is height balanced. And if it is equal to -1, that means that there is an imbalance within the tree. Let's see if the code runs or not. Let's see if the code runs or not. It definitely runs. So this we will try to sum it up and let's see if there is any failure. There is no failure, guys. I'm surprised. But anyways, that's my take on this thing. I hope you enjoyed the video. Thanks. Do like and share with your friends.